big thank you to the the Port Townsend Marine Science Center and the MRC at Jefferson County for the invitation to speak to you today. I always enjoy this. Normally, I love doing these type of things in person and getting the feedback from everybody, really being able to do these kind of questions in real time, which I think fosters really great discussion. But unfortunately, given the virtual nature here, we'll have to hold off on those questions till the end. So hopefully, if something comes up in your mind, either just shoot it into the chat while I'm talking, and then we can come back around to it, or write it down and save it for later. So with that, I do have to do a little bit of a disclaimer here at the beginning. If I refer to any products, trademarks, or manufacturer, it doesn't constitute an endorsement by the U.S. government. Furthermore, while I do work for NOAA, what I'm going to be talking about tonight is going to be a lot of my own personal opinions and may not represent exactly what NOAA's position are on some of these things, or the government. So with that out of the way, I'm going to go ahead and get right into things. So today I'm going to talk to you kind of over three things. What is marine debris? Then getting into some specifics about microplastics. And then if we have time at the end, I'm going to talk a little bit about NOAA's marine debris program itself. So hopefully we'll have time to go through all that. If not, I've structured this in a way that we get through hopefully mostly the interesting things around marine debris, and we can save some of the programmatic things for later if not. So what is marine debris? Well, I'll tell you, there is a very specific definition, which I will read to you because it's a little bit clunky, but it is the official NOAA definition of marine debris. So NOAA defines marine debris as any persistent solid material that is manufactured or processed and directly or indirectly, intentionally or unintentionally disposed of or abandoned into the marine environment or the Great Lakes. So, but basically what that means is anything that's man-made or altered by mankind and ends up in the marine environment is marine debris. So things that aren't marine debris would be, say, a driftwood. Driftwood is not marine debris, but if it's treated by creosote or pressure-treated lumber, then it's marine debris. So a little bit of a distinction there, but it comes in so many different shapes and sizes. So what I've got here is some pictures of examples of marine debris from macro to micro. So on the right-hand side, we actually have a whole bunch of vessels that have washed ashore, probably in a storm. This is in Alaska, actually. So everything from as large as vessels down to that tiny little speck of plastic on the thumb there in the middle. All of that, and in between is marine debris. We got some floating consumer debris on the left with the diver swimming, and then something that is more common to the Puget Sound and the Pacific Northwest in general is these crab pots that you actually see in this vessel, the small boat down the center there. And those are actually abandoned and lost derelict crab pots. And I'll get into some more specifics about all of those, but really our oceans are filled with items that do not belong there. Huge amounts of consumer plastics, metals, rubber, paper, textiles, like I said, derelict fishing gear, vessels. I got the picture there. Other lost or discarded items, and they enter the marine environment every day. And this is one of the things in my old job. Before coming to the marine debris program, I did a lot of work in contaminants, chemical contaminants in the environment. And explaining chemistry to people can be a challenge, but marine debris is a very understandable, very approachable issue. It affects everybody, and it's visible and very easy to see. So I'm really happy that I get to give this talk before the International Coastal Cleanup, when hopefully many of you will be out there on the beaches. I'll be out on my local beach doing some cleanup, and you get to see kind of firsthand and really be a part of the solution to this problem facing the world's ocean. And it is a global problem. And I'll get into a little bit more about kind of the movement of marine debris throughout the ocean. But then the final thing before we move forward is, most important, marine debris is preventable. It is a preventable issue. So starting with the biggest things, marine debris, types of marine debris. I've got some pictures here of some very large pieces of marine debris. Some of these might look familiar, like these two in the upper left-hand corner here, moving clockwise. So these two dock segments, these are floating dock segments. they showed up on Washington and Oregon's coast. I can't remember which, off the top of my head, which one of these was in Washington, which one was in Oregon. Ultimately, it doesn't matter. They both came from the Japanese earthquake and tsunami of 2011. And a couple years later, they showed up on our shores here. That means that they floated across the Pacific Ocean all the way from Japan all the way to us here over 2 years. Another example here on the upper right hand corner is another piece of debris from the Japanese tsunami. That is a vessel that floated upside down all the way across the ocean. You can see where they actually cleared a portion of the hull off so they could do some identification of the lettering there. But you can see it's encrusted with all these bivalves, these barnacles. Same with these two dock fragments too. In the lower half, we have some examples of large marine debris that are not in our area. The bottom right is the Costa Concordia. I don't know how many are familiar with the gigantic cruise ship that ran aground in Europe. That is marine debris. It was huge and just immensely costly to get that off the reef in one piece. An amazing marvel of engineering, that getting that off the reef. On the lower left, we actually have a sailing boat in St. Thomas that was sunk during Hurricane Maria. This is one of thousands of boats that went down in Maria and the other hurricanes that went through and are sunk every time a major storm goes through. So marine debris is an endpoint often of many storm events and becoming more and more prevalent as the storms become more frequent and more powerful. And then that one picture in the middle there is actually a picture I took myself. This is from a study I was doing in Vieques, Puerto Rico. A little story around that. The island of Vieques was a former surface weapons naval training facility where post-World War II, the Navy annexed 2/3 of the island, stored the munitions on the west end, and had live bombing on the east end for about 60 years. And then post-2003 was turned over to the Fish and Wildlife Service for wildlife refuge in perpetuity. And they were doing, and still ongoing, doing surface cleaning of unexploded ordnance. But my group within NOAA was brought in to do a contaminant assessment of the marine lagoons on the island. And I was in my little kayak paddling around. We had a ordnance specialist with us. And he assured me that this was well outside the former impact area, so it shouldn't be an issue. And so I'm paddling my kayak with my little GPS and come paddling around a corner. And what do I see is this Acme bomb sticking out of the water. Thankfully, he determined it was a practice bomb and was not armed, but still rather alarming. But goes to show you that marine debris can take many, many different forms, including unexploded ordnance. So moving forward, what about some more debris items that might be familiar that you're going to see probably this weekend while you're out cleaning? All of these pictures were taken along the outer coast, along the beaches, from one of the projects that NOAA supports with the Grassroots Garbage Gang out in Long Beach, Washington, which is far south. There's a group out there led by a wonderful volunteer named Russ Lewis, who patrols this whole section, 7 miles of beach, and cleans up debris. NOAA supports through one of our grants through a beach dumpster that we help do the rental for and the change out. But anyway, here you can see these look like consumer debris items that can travel long distances. In the upper right hand corner, this is an antifreeze bottle. Looks pretty familiar. Might be from local source, but who knows where it could have come from. In the center there, you see some with foreign writing on it. Could have come a long ways, could have come from a local source too. It's really, really hard to know where these things are coming from. There is a fishing bullet float in the bottom left there. Looks like it's up in the dunes, kind of being covered over. This is a common thing, especially with, I don't know if when you're out, have been out doing beach cleanups, you see those little yellow rope fragments about 6 inches long. Those are very typical. That's actually from aquaculture. And I can talk a little bit more later about those specific debris type if people are interested. But they tend to, these items can get buried in the surf, get buried in the sand dunes, and can be there for years before one of our king tides comes in, and it just stirs everything up, and years old debris that has been buried can be resuspended. And then you can see there's another couple of examples here of gooseneck barnacles attaching. These are clear indications of being out in the ocean for a long period of time. This flip-flop probably was floating upside down, and the barnacles were able to attach and really grow to quite a large size. You can see that they're probably not happy now that they're on shore. But as an example of how invasive species can be moved across the oceans, be either attaching to marine debris like those segments of dock. So those Japanese Misawa, Japan dock fragments. Fish can hide out underneath there and basically go across the entire ocean. You can have these barnacles, other invasive species, and I know that my colleagues within the state Department of Natural Resources and over at Fish and Wildlife, they were out very many times really doing intervention to keep these organisms becoming invasive on our shores. So a whole host of kind of impacts outside of just the debris itself that can come along with it. And I do have a slide here that focuses on derelict fishing gear, just because this is a very common issue in the Puget Sound and in the Strait of Juan de Fuca. So derelict fishing gear, really the common one here is the crab pots. So I've got two pictures here of the net and then an example crab pot. So an example of how a crab pot can become marine debris. A recreational fisherman may not be too experienced, can go down to his local shop, his or her local shop, get one of these crab pots for fairly cheap. It comes with everything you need, a weighted line, a float, and the pot itself. You go out there, you toss it over the side, and you think you're good. Well, there's many different considerations that you have to take into account, namely weighting these crab pots so they don't move away. So you think you got a float up on top, the line goes down, the crab pot's on the bottom. If you have too little line out, when the tide comes in, the whole thing can float up off the bottom and the tide goes out and you come back and your crab pot's not where you left it. That's a lost crab pot. You can also have an instance of overweighting your pots. So then you toss it overboard, you didn't have enough line on it. And I've done this with sampling gear before. Thankfully we were diving, so we went in the water and got it back. But the line was too short, tossed it over, was supposed to have a float at the surface, and I just watched the float disappear under the surface of the water. So if you are out and you have not had enough line, you have your crab pot properly weighted, and you toss it over, and suddenly that float disappears beneath the waves. Another example of this could be it could be fine. You are out at low tide, you toss it overboard, your float's sitting there. High tide comes in, and you come back, and you can't find your float because it's underwater. It's still in the same place, but it's underwater. And then finally, another way that these crab pots are lost is everything can be right, but you might have put it into a shipping channel, or a boat goes by and it gets caught on the boat, it gets caught in the prop and the line gets cut. These are all ways these crab pots end up being marine debris. They can sit on the bottom. And here's the kind of the unforeseen, or another aspect to these crab pots as marine debris, is they're designed very, very well engineered to catch crabs. Normally, they catch crabs, you pull it to the surface. They got, if you can see on this one, there's actually a little escape ring on the side here that allows the undersized crabs to get out. The regulations are that no female crabs are to be captured. Crabbers toss them back over the side, and only the males of a certain size can be captured and be part of the take. Well, when the line is cut, this thing is still doing what it was designed to do. It's baited and the crabs are attracted. Now they can't get out, including the females. So the small ones can still get out through the escape ring, but now then there's nobody who's going out to pull this back up. So those crabs are inside there. They can result to cannibalism, where they start eating each other, or eventually they may die, which then attracts more crabs, which then get trapped in there and can't escape. And the cycle continues. This is called ghost fishing, and it's the same with nets. Nets are designed to capture fish, and when they're out there no longer being tended, they become very much entangled, and you'll get lots of other unintended organisms caught in it, and they can attract other animals to it because of this basically is as a food source, and it just continues to fish over time. It's called ghost fishing. And from an economic standpoint, this is really harmful. You're removing from the resource, but not getting the economic benefit out of it. So it's really kind of a win-win scenario for the marine debris program to fund projects to go out and remove these from the environment. And then there's also engineering built into these to help avoid the ghost fishing, especially on these crab pots. You see this escape ring. They are now required to have rot cord on them, so that it may take 60 to 120 days, but eventually that cord will rot out and that ring will fall out, and then all the crabs can get out of there. But that's a really common issue here in the Pacific Northwest. Now transitioning to kind of the main event, plastics. So common form of marine debris. It's non-biodegradable. It's persistent. They can last a long time. I don't know how many people are familiar with a container full of rubber bath toys that went overboard off of a vessel in about 40 years ago, 30, 40 years ago. And they are still finding these rubber duckies and turtles and things washing up on shores. They went over in the Pacific, and they've showed up in Europe. So just to give you an example of the global nature, and years later, 30 years later, I actually just saw a notice today, late last week, of float cards that NOAA put out to study ocean patterns 45 years ago, and two of them actually washed up on shore in Europe just in the last few weeks. 45 years of being out in the ocean and washing up on shore. My colleague out in Hawaii contacted me a couple months ago because some of the plastic plaques that go on the commercial crab pots showed up on South Point of Hawaii. So the crab pots probably became derelict, and those plastic pieces broke off, and they ended up in all places on South Point, Hawaii. So estimated 8 million metric tons of plastic enter the ocean every year. And I'm sure some people have heard this, the phrase, so there's going to be more plastic than fish in the ocean. That's a pretty misleading statement, and there's a lot of different things that go into that. I would not say that. I would say that just know that there is a lot of plastic that ends up in the environment. And now the next thing that kind of leads into these microplastics is really, well, these things can break down into smaller pieces. Smaller pieces don't necessarily mean they're degrading. So when you talk about breaking down, there's kind of two paradigms to think of. When you think of something degrading, you think of something kind of, at least when I do, I think of it breaking down into its chemical constituents, meaning that it is truly breaking down into its to usable pieces in the environment. So think a bacteria is actually digesting the plastic, breaking it down into its atoms again, so that can then therefore re-enter the food chain and be part of something else. But then there is breaking down into smaller pieces. Think of a sheet of glass. You have a sheet of glass, you throw it down on the ground, it is broken into 1,000 pieces. It is still fundamentally, each one of those pieces is still glass. It hasn't changed, except that there's more of them and they're smaller. And that's the idea of microplastics. So those two kind of ideas of breaking down chemically versus breaking down into smaller pieces. So the idea of degrading versus breaking down. And NOAA really doesn't have hasn't really come to a conclusion on the degradation rates of plastic, but just know that many of them can be in the terms of years and years. I've seen some, and this is my personal opinion here, is some that can take hundreds of years to break down, to degrade. Then these things can become entrained within ocean currents. I'm sure some of you have heard of the Great Pacific Garbage Patch, and think of this as a gigantic gyre in the Pacific Ocean. So when I say a gyre, I'm talking about a circular current that's large on the scales of thousands of miles across, that spins in a clockwise fashion in the Pacific Ocean. But this is really spread out. So even this picture here I have up here is not really representative of what you might see in the Pacific gyre. I have some pictures later of that. So microplastics. The definition of microplastics is plastics that are smaller than 5 millimeters in size. So think of something that's smaller than a bottle cap off of a soda bottle, a pop bottle, whatever you want to call it. So most of these pieces, I would say the majority of these pieces are not primarily designed as microplastics, meaning they've broken down from something larger into these pieces. That's not always true. There are some, or used to be some, primary sources. Think of there used to be products that had microbeads in them, toothpastes, facial washes that actually had little bits of plastic in there that were designed as exfoliators. And once that was realized that these were ending up in the environment, most places have outlawed them. They're not allowed anymore. So if you're finding them, they're in the US at least, they're usually from existing stocks, nothing that's been made new. Another one that might be familiar is the idea of a nurdle. That's not a term that NOAA has, but it is a nurdle by definition is a piece of plastic that is in its raw form that is designed to go to a manufacturer. So little pellets of plastic that can be melted down and then created into a product. So those would be examples of primary sources of microplastics. Most plastics, microplastics, are again breaking down. So that can be this example here in the middle is a little piece of expanded polystyrene. Uh, that meaning could be from like a packing peanut, or another common one is you go to a grocery store and they have those disposable coolers that are made out of polystyrene foam. And when those get left out on the beach after, 4th of July, whatever, the waves come in, the wind comes, it breaks it apart. They break down to these little pieces, these little foam pieces. Another common one that may not be as well understood or well recognized is microfibers. Every time, every time you wash your clothes, think of when you toss your clothes into the dryer, and then you have to clean out your lint trap. It's got all those fibers in there. Well, that's what you see in the dryer. You would also see that in your washer too, but most of those fibers are actually in the water and they're washed out down the drain. There are products that you can get to put on your washer to kind of intervene, and a lot of commercial places have those too. But those are all examples of microplastics and how they can enter the environment. There are impacts. Plastics of any size can be ingested by organisms and have physical impacts. There's also chemical impacts. The chemical impacts, I will say, are not well understood right now, but uh, in the same sense that oil and water don't mix, uh, plastic, most plastics are made from petroleum sources, so oil products. And from a chemical standpoint, oil, water don't mix. A lot of chemicals of emerging concern, chemicals of past concern, meaning DDT, PCBs. So I'm sure many people are familiar with DDT, and I promise you I won't go too much further into the chemistry here because I can already hear, people's brains shutting off. But the chemicals that like attracts to like. So think of magnets attracting to each other. Plastics in the water column can be something that those chemicals will adhere to. And well, it's not well understood at this point how that impacts organisms or birds, fish, ourselves. It is a potential pathway for moving these chemicals around the environment. And these things, so plastics continue to break down through wave action, through exposure to sunlight, through physically being uh, uh, preyed upon by fish, by birds. A common thing you might see when you're out doing your beach cleaning is plastic that has lots of holes punctured into it, or seems to be all ratty and really kind of torn apart. That's often from seabirds trying to feed on it because they think it might be food. Another picture here, this is a very common of what you would find in the Great Pacific Garbage Patch. So often a very common type of study that is done is through plankton trawls, which is where you throw this very fine mesh uh, out behind a boat and you pull it behind the boat for a set length of time, and you come up and you weigh it to see how much plankton there is in it. Well, in the 70s, 80s, 90s, our researchers started finding more and more examples of plastic showing up in those trawls. And then they started recording that. That's how the Great Pacific Garbage Patch was really first kind of described. It's like, wow, there's higher density of these microplastics in these certain gyres in the ocean. And there are actually 5 gyres in the ocean. Again, the most well-known one is the Great Pacific Garbage Patch, but this is really common of what you would see. You have a blue plastic here, some microfibers, you have expanded polystyrene beads here, there's 3 of them, and then there's even a piece of yellow polypropylene rope fragment right here too. And these tend to get very brittle when they're in the sunlight, and they can break down into these smaller pieces. Well, what about different types of plastic? Because not all plastic is the same. So I've listed here 2 different sources, but just to give you a real brief idea, these along the bottom, these recycle symbols might look pretty familiar. Different types of plastic, and those correspond to these types here. This is actually from a study looking at the instance, so number of studies that actually said that they found these items. So you can see that it's actually in order of most common to least common from this meta study that was done of other studies out there. So the most common type of plastic in the environment is both high density and low density polyethylene. Those are your milk jugs, your plastic bags, your 6-pack rings, bottles, drinking straws. The next one was polypropylene. So that's the yellow rope that floats, also bottle caps and some netting, and on down. I won't read all of them, but all different types of plastic that all chemically can behave differently, can break down differently, can persist different lengths over time in the environment. And I will say, just because something has this recycle sign on it that you have along the bottom here, does not actually mean that your local recycler can recycle it. You know, I was guilty for a long time of being a wish cycler, meaning that anything that I thought, oh, this should be recyclable, I would throw it in recycling. And I've learned a lot since joining the Marine Debris Program about what is actually recyclable. And so I am by no means an expert when it comes to recycling, but if you're curious, you should call your recycler, your local recycler up and find out what is actually recyclable, and what besides what you're putting into your recycling. So what about compostable plastics? This is always exciting to me. It's like, oh, this is something that will break down. I can feel a little less guilty about it. Compostable is a very specific term in the recycling world. Compostable plastic doesn't mean that you can toss it into your little garden recycle compost and it's going to degrade. No, compostable in the larger waste stream has a very specific set of conditions that are required, meaning you have to have a very specific set of soil with bacterial colonies that are present, and heat and energy all put in for these things to break down. So this is actually, I have 2 pictures here from a study that was a publication by 5 gyres. Again, that's a reference back to those 5 gyres of plastic in the ocean, but it's a group that did some studies around compostable plastics and what happens if you put those directly just into any landfill. So what you're seeing here in this first column is kind of the original piece of consumer product. Then the first one is 6 months in a landfill, 12 months in a landfill, and then 2 years in a landfill. And then this last column is 2 years in the ocean. So what you're seeing is, well, these things are breaking down. Often they are not actually degrading. So again, there's nothing against these products. It just means that you have to understand that when something says it's compostable, there is usually a very specific set of conditions that are required. And here you have some plastic bags on the right. So not surprisingly, in the ocean, you don't see a lot of these things breaking down. And when you think about it from a bacterial standpoint, these conditions that are required for these things to actually be degraded, where the bacteria are on the surface and they're just kind of eating away at those surface layers, layer at a time. When you have those conditions within the industrial compost, where the heat's right, you have the right microbial conditions, the soil is right, then that's a very controlled environment, and those bacteria can thrive. In the ocean, you think about it, you have a very harsh environment, and it's constantly being washed over, and the sunlight and the waves, and it's always being disrupted. So things in the ocean can tend to persist a lot longer than on land. What about, so this is a slide here I like to include because it's it's a few years old now. It's 2017, but it's talking about projections of our overall primary waste. So the black line there is, if we continue on our current path, that is the projected uh, overall waste we produce. So meaning we are producing a lot more waste over time. The important things here to pay attention to are the red, green, and blue lines. So what we want to see is the red line underneath both the green and blue. So the red line is all of our waste that is actually discarded. So the black line is all waste, but we are recycling some of that and we're incinerating some of that. And the red line is what is actually going into a landfill. So where we want to see is that red line to continue going down and those blue and green lines to go up. Really, ideally, we want to see a circular economy with that recycling is occurring and those products are just continually being used over and over and over again. Uh, the green line, incineration, I can go ahead and say that that's not a perfect solution. Definitely not. I mean, when you burn something, we are still creating some form of atmospheric release, greenhouse gases, but is that better than going into a landfill? So again, we want to really see that blue line coming up and that red line going down, and then the green line being somewhere in the middle of better than just going into the landfill. And now I have the next few slides is just some examples of studies that are kind of come out. These are 2018 or so, but again, it's just getting you an idea that this is still cutting edge, that we don't understand well yet. The science is ongoing. I was in a meeting today with in the Pacific Northwest Consortium on plastics, where risk assessments are being done around microplastics as a vector for contaminants entering our seafood, and there's nothing definitive yet. It may be that it isn't really the driving factor. It may well not be negatively affecting. So just here as examples, it's showing that microplastics are showing up in our seafood. Whether or not that's problematic, we don't know yet. It may well be that it really isn't. So just want to be very transparent here on that. Uh, Microplastics here, these researchers saying could pose a major threat to whales and sharks. Uh, Seabirds are, I don't know how many are familiar with the albatross. So the albatross birds, when they fledge, the eggs are laid on islands out in the Pacific, much and very similar to say owls with their pellets. I don't know if you're familiar or not. Owls, when they eat, they end up disgorging all the undigestible parts of their diet out in these pellets. My dad used to take me out when I was a kid, and we would dissect owl pellets. I know, right? I was really into the really cool stuff as a kid. But I really loved it. But the same principle with albatross, with what they have is they call a bolus. So when these juvenile birds are ready to fledge and fly, they will disgorge all of those undigestible portions of their diet. And historically speaking, that would be things like uh, beaks of octopus, and the pens from squid. So there's kind of hard undigestible things that they would normally disgorge before they went flying off as adults. Now you can dissect those and you will find plastic all over in those. And sometimes they eat so many pieces of plastic that they end up dying. You can see pictures of these dead juvenile birds, and they're basically, their stomachs are just full of plastic. So plastics and microplastics can be a real hard thing for birds. And then we found microplastics in human waste too. I'm glad I wasn't involved in that study personally, but just something to be aware of, that we are also part of the food chain. So again, that's no comment on whether it's negatively impacting us, but just to be aware of. So what can we do? Well, the biggest thing, and again, really proud that we're going to be all going out to do the International Coastal Cleanup this weekend. That's a real good one. Again, that's removing things that are already in the environment. But what about preventing things from getting into the environment? That's really the kind of the keys here. Oh, this is an older slide. So from an example of working with restaurants to really reduce the takeout plastics, and that's been a big thing during the pandemic. A lot of people are doing a lot more takeout, and having those options where we do have those non-plastic opportunities, or the ability to opt out or to have to opt in to get some of those plastic items. And I'm really focusing on single-use plastics. I mean, plastic is a wonder material. It really did revolutionize our lives, and it is valuable and an extremely important part of our economy. But really, it's those single-use plastic items, something that you use once and throw it away, and then it's in the environment for long, long time. So think a disposable utensil, a fork, knife, a spoon, a plastic wrap that, I actually saw a banana in a plastic wrap. It's like, why? So this is a piece of plastic that you're going to open, use once, and it throws away. Those are the ones we want to really avoid using as much. So identifying those barriers to plastic-free choices, and those are the important things. What can we do personally? But then there's options where you can approach this from a policy standpoint. Those are really outside of my wheelhouse and my role here, but happy to talk further on those. So at this point, I'm going to transition away from marine debris and plastics, and I'm going to talk a little bit about NOAA's marine debris program and how we as a program really work to address the issue of marine debris. And I've got some really big picture things on here that are from our strategic plan, our mission, and envisioning a global ocean that's free from the impacts of marine debris. I have to say that I feel like I have some pretty great job security in this role, but I would love to be out of a job someday. Then we don't have to worry about marine debris. And then some really core themes for us: diversity and inclusion. In our both in the way we deal with our partners and NGOs, universities, but also in our grants. Want to make sure that we're being diverse and inclusive there. Zero waste policies, and really, again, around this prevention focus. That's our number one core: is how do we prevent things from becoming marine debris? So really briefly, the Marine Debris Program was established by Congress back in 2006 through the Marine Debris Act that was re-upped not too long ago. And the act requires our program to, well, I won't read the specifics there, but there are some very, boilerplate language in what the Marine Debris Program is authorized to do. But we really approach that through a regional coordination paradigm. So the idea here is that the issues are going to be different. We have a huge country especially when you consider Alaska and all the Pacific Island territories, the entire Pacific coast, the Great Lakes, and all of the Gulf Coast and the Atlantic coast. We have a huge coastline that has different issues everywhere. So by having this regional model, we can have people who are in each region and can be integrated into the community and be aware of the specific problems of the community. So I'm here in the Pacific Northwest. I have 9 other colleagues that do what I do. As was stated earlier, I'm also the team lead for the Pacific, so I oversee the California, Pacific Islands, and Alaska regional coordinator as well. They do the same things that I do here in the Pacific Northwest, but as a whole entity for the Pacific. And then we have an Atlantic team as well. Recently, some legislation that I think I'd like to point out for you is the Save Our Seas 2.0 Act that came out on December 18th, was signed on December 18th of 2020, and it has implications for NOAA, EPA, and the State Department. But for NOAA specifically, the big one is the creation of a Marine Debris Foundation. And so that is ongoing as we speak. You might have seen that there was a call for applications for the board. So the selection process is happening right now, and hopefully we can get that stood up pretty soon. And that'll be another central focus area where people can come together and either through funding or donations, really another way to address the issue of marine debris. There's also a Genius Prize in the Save Our Seas Act around innovation. That NOAA will be administering. And then there's several new reports that are mandated: an abandoned and derelict vessel study, a derelict fishing gear study, and then a study around the US contribution to global plastic pollution. And then finally here, before I move into our grants, these are the core pillars from our newest strategic plan. Again, prevention being the main one, but we have these core pillars of removal, research, monitoring and detection is a new one in this new 5-year plan that wasn't in our previous one, response, and then coordination. So this is a 5-year plan that was just signed. We've the end of this month will be the end of the first year, and it's really designed to drive our daily operations, set those big picture things and the annual milestones for us to really stay on track and get them be the most responsible that we can be with the appropriations of public money that we've been given, and that really turns to our grants. And the main one that we spend a lot of money on is removal. It's a very tangible thing. I mean, how much when we spend these public dollars, how much money are we spending to remove how many pounds of debris? Here's an example of pulling out one of these ghost nets. But this one picture I really love here is one cleanup of some of the Northwest Pacific, Hawaiian Islands. You would think that being so remote and away from any kind of humans living there, they might be more pristine. But the reality is with not having humans there to clean up, they tend to accumulate a lot of debris. And you can see this example of one island here, they've staged it. And all those fishing floats that are up here in the center, smaller floats here, a small boat, you have shoes, you have nets and ropes, and over here are just the bottles that have been collected, and even a bumper of a car. It's amazing what you'll find out there. And then just finally here before I end talking about our grants, NOAA has grant opportunities every single year. Every year we offer a removal grant, and then we alternate on opposite years between research and prevention. So this year, FY21, we have removal and research that were funded. Right now, I can put a little plug in here for we have 2 opportunities open as we speak. There's a removal grant that's open through the end of September 24th, 2021. That will close for removal, still accepting letters of intent. And then the prevention grant just opened now and will be open through October 24th. So if you have any interest in those, I'd be happy to talk with you later. If you want to bounce some ideas around, but really, again, just happy to talk. My role, I view it as not just around the grants, but really making connections between the people that are doing this type of work, which is why I was really happy to be able to connect with the Port Townsend Marine Science Center and the Jefferson County MRC. You know, it's these type of connections that really drive the work getting done. So with that, thank you so much for your time. I really wish I could have been there in person to answer your questions in real time, but I'm going to hang around here and answer any questions you might have. So thank you so much, and I'm going to stop talking it for now.